Let's talk about the idea of increasing and decreasing functions. This seemingly simple idea is actually a little bit more than we'll give it credit for. So if we're talking about increasing and decreasing functions, I like to relate this back, again, kind of to a story or to a picture. Because if I was going to describe something that was increasing, I might describe it as something that was going up, like a increasing hill. But we have to be careful when we're talking about if this hill is increasing, because are we walking along it this way or are we walking along it this way? One is going to take us higher, the other is going to take us lower. So maybe we'll start off with the standard of just simply saying that going to the right is going to be the positive direction of our travel. So this is going to be the direction that we're kind of using as default, and it matches up very nicely with our normal coordinate system. And so we'll say if we're heading towards the positive direction of our inputs and our outputs are getting more positive, then we can kind of correlate that to saying it's as if I'm traveling across a hill, but I'm traveling in this direction. So this is going to be the pictorial version for saying that I'm increasing, is if you imagine walking from left to right, that your next step would take you higher. Now, the challenge with this is that it's not very technical. The reason why it's not technical isn't because it needs fancy sounding words. It's because you get into some ambiguity at some of these extreme situations. Like, for example, let's take this graph and give it a lowest point and let's give it a highest point. And let's say that we are at the very top now. At the very top, my question for you is it increasing or is it decreasing? Well, there's an argument to be said that it's decreasing, because at the top, if you talked about your next step would be able to take you to one thing that is less, so that would possibly be decreasing. But then that would mean at the bottom over here, this would have to be increasing. But all of this was with the assumption that we are walking from left to right. If we walk from right to left, we could have described this entire situation in a pretty similar format that would have gotten us a very different answer. For example, I could still have described this as increasing along this stretch if, as I walked backwards, I would have gone lower. In other words, if I came from a lower place, then I must be increasing because I've traveled higher. Do we see the logic? At that logic, though, if I'm looking for the thing happening right beforehand, at the top of the hill, that means that I came from a lower place, so I must be increasing, when I had just said before that I was decreasing under the other perspective. And at the bottom, that would mean that I was decreasing, even though when I was walking left to right, that was when I was increasing. So we get into some confusion area here when we're talking about increasing or decreasing, and it's something that's worthwhile kind of trying to put a pin on as we try to make this more formal. So instead, what we're going to try to do is we're going to try to make a claim. We're going to try to claim that we are increasing on a certain stretch, like maybe between the two circles that I've drawn here, and we're going to verify that by saying that if you choose an x value that is less than another x value, so we'll call this one x1 and call this one x2, that x1's height just simply needs to be below x2's height. And if that's the case, we will call this stretch increasing. And the same thing is going to happen for reverse, but let's write down the more technical details real quick before we lose it. So we're going to say that increasing on an interval is when, for some x1 and x2, with x1 less than x2, f of x1 is less than f of x2. Now, this is where taking good notes becomes really important. And taking good notes does not mean writing down what I write down. It means writing down what I write down and then taking time to write it in your own words as well. Because this is something that may make a little bit of sense now, but if you look at it in a month or 2 months, will likely not make any sense. So you want to take time to write this in your own words. So I'll reiterate again what all of this says in less technical detail. What this says is that if you claim a stretch, a continuous stretch on the x-axis, to say that it is increasing during, that means that you can choose a moment before and a moment after, where the moment before's height is less than the moment after's height. And that's all we're saying, is that I came from someplace lower and I'm about to go to someplace higher, and we'll call that increasing. Now, this part has also a little bit of challenge because am I increasing or decreasing at the highest points? I need to choose two things that are on the interval at the highest points. But it doesn't say that, for example, if I was to make this point right here now be x1, where would my x2 go? Or if I was to make this one over here be x2, where would x1 go? Do I need to always have x1 be on the left of an x2? I need to always have the ability to have both x1 and x2? Do I need to be able to have 2 points on a stretch? Well, yeah, the way that we have it written here, I need to have 2 points, and at the extremes, I only have one x value. I can't have the extreme x value be less than itself. So we get into a conflict within the logic of our definition when we start to talk about the extremes here. And so the way that we settle this in a nice, elegant, simple format is we just make the claim that at the very top and at the very bottom of your hill, you are neither increasing nor decreasing. We're just going to say that you're not doing either. You're at a moment of change. You are transitioning from one thing to the other, and at that moment, you are not doing both. You're just not doing either. So we will say that at the extremes are neither increasing or decreasing. Now, the nice thing about this definition is if you take, let's say, something that's a very crazy looking hill, maybe with an asymptote in the middle, a zero division error in the middle, and you say, well, what is happening at the graph right here at this problem? Nothing. It's neither increasing nor decreasing. It doesn't exist. You can't find two x values that are both of that problem, so there's not a problem to worry about. So this idea of increasing and decreasing works very well if you are inside of a stretch between extremes. For that reason, we will always be describing intervals of increasing and decreasing using parentheses and not brackets. So, for example, in this one here, if this is an x value of 1 all the way until an x value of 5, we could describe this as saying that it is increasing on the interval 1 until 5. And if we say that nothing changes before or after, we can say that it is decreasing on the interval starting as far back as forever until the value of 1, where we don't include 1. That's all of this. So in other words, all of these x values, if you were to go right above it, you would be able to see that it is decreasing because you could find two values and compare them all the way until you get to 1, where 1 has a situation where it is neither increasing nor decreasing, so we'll use a parenthesis to just use it as a reference point and not actually include it. And then we'll pick this decreasing behavior up right afterwards when we get right past 5, and we'll go on towards positive infinity. And this is how we're going to be describing increasing and decreasing, is that increasing is whenever you can find 2 points, which means you have to have an open interval, and on that open interval, those heights have taken you from what used to be lower to something that is now higher, and vice versa for things that are decreasing.